Welcome to the 10th video in this series making a 2D top-down racer using Godot. In this video, what we're going to do is we're going to get a simple version of the AI car driving around the track. As a little bit of a forewarning, make sure you're feeling fresh for this one. It's a little bit more complicated than what we've done so far in the series, and there's more than a high probability that I will make some kind of mistake as we're going along, but I promise we'll fix all of the bugs and things by the end of this particular video. So let's get cracking. Okay, so the target then is to make a very simple AI car that follows the waypoints around the track. Let's open up the cars holder and open up our car scene. So our car scene contains everything we need for the player car, but it also contains everything actually that we need for the CPU car as well. And in fact, if I drop into the script, the states that we have here will apply to the CPU car, and later other states we'll add will as well. The car name, the car number, not all of these here. The bounce time, the bounce force, the slipping, these all apply to the CPU car. It can also hit walls, hit oil slicks, spin, things like that. So when you come across this case, usually it's a good idea to actually use inheritance such that you can have a base class which has functionality that's shared, and then you can extend that as you need. And that's what we're going to do here. Now, I would advise that you make a copy somewhere of the project that you're working on at the moment, because what we're about to do is make a base player car and try to extract the things that are player car only and leave the things that both need in the base class. And there's a little bit of chopping and changing we're going to need to do that. And you're probably quite right to question me in terms of why I waited so long to do this before tearing this to pieces to create the player car. The reason actually was I didn't want to use the inheritance straight away at the beginning of the series because I thought that might confuse people. So hopefully that's okay for you. Okay then, so what we're going to do then is create our player car. So I'm going to go to Scene, New Inherited Scene, and then select the car as the base scene and click Open. With all this being yellow here, that indicates to us that we've got a scene that's inheriting from another one. It may look the same with the same name, but these yellow nodes indicate to us that we can't modify these because they're on the base scene. We're not allowed to change them. We also have the unsaved here telling us that we've got a brand new scene. So what I'm going to do is Control S to save, and in the same folder actually as the car, save this as playercar.tscn. And then we should also probably change the root node here as well. So I'll change this to player car. Okay, so what we want to do is we want to add custom functionality onto the base car. And in fact, we want to move some of the base car's properties and functions into the player car because they're not related to the AI car. To do that, we'll create another type, which will be class name player car. We can't do that in this script though, because this script is attached to the base class here. That would be a bad idea. So I'll select the player car scene, make sure you have the player car scene selected with the root node selected, detach the existing script, create a new script, and click the little list here. And if I type car, we should find our car type actually in here. There it is. So double click on that. Now we're going to make a new script inheriting from car, and we've got the path playercar.gd. We don't need any template actually for this at all. That looks good. I'm going to click create. So now we have a script where we are extending car, but this is actually going to be player car. And in fact, the first thing we can do here is actually define this class name before I forget this for later on. So this is going to be player car. Now we already have something we have to be careful of here, and that is with our verification. So if we go to our verification.gd, here we're checking if what hits us is a car. And if it is, then we're going to invoke this hit verification. Now this verification is not needed for the AI. It's only needed for the player car because the AI will only ever go forwards. AI, as you know, never cheat. So what we'll do is we'll change area to area is player car here. And we're going to move this hit verification actually onto the player car and away from the car. Now, I want to double check where we've got in our project area is car to make sure that anything else that we have is okay on the car. So I'm going to go to search, find in files, and search for area is car. I don't think we've got too much. Let's have a look. If I do find, so with the oil, well, both are going to hit that, so that's okay. And here we've got hit boundary. That's okay as well because both of them can hit boundaries and both of them also can complete laps. Okay, so the rest is okay. The main one was the verification here. So let's go back to the player car. What we need to do now is add the functionality in here that's specific to the player car, of which a lot of it is in car. So let's have a look. We've got car name, car number. That's not specific, but the max speed, the friction, acceleration, steer strength, and min steer factor, they are all irrelevant for the AI car. We're going to use different settings and ways of doing things there. So we don't need these actually on car. So I'm going to select these and cut them out. So we're left with bounce time, bounce force, and slip speed range. Save that, and then go into the player car here and paste these at the top here. Next, let's go back into car. We're going to have a load of red inside here. Don't worry about that. We'll fix all that. I'd like to go down a little bit more here. So we've got the throttle, the steer. Those are both going to only be needed by the player car. So I'm going to cut those out and go to player car and drop those in here. We're going to do things in a different way, as you'll see with the AI. Let's go back to car. What else have we got? We've got velocity, both will have. Bounce tween, bounce target, slip tween, state, they'll have. Verifications. So the verifications are only used by the player car. So I'll cut those out and go to player car and drop those in here. We still have red. Don't worry about that. It's because we've not saved car yet as its type. So it's still got all of these registered in this particular type. So scrolling down then a little bit, we have this setup function here, which is taking in the verifications count. So we can take that away as well. We can always add it back in the base class if we need it for both, but we can actually take that and put that in the player car as well. So we'll go down to here and we'll put that in the player car, and we can delete the pass, I think, from here as well. Okay, let's go back to car then. What else do we have? So we have the process function here where we're incrementing the lap time in the delta, but we're also getting our inputs. Now that's clearly not something for the AI. So I'm going to get hold of the process, copy that, go into player car, make some space here, and drop that in here. Now the lap time will be incremented for both the AI and the player car. So what we'll do is we'll delete that from here, go to car, and then I'll delete from I'm in car here, so delete the throttle and the steer, we don't need it, but leave the lap time incrementation here because it will be done for either an AI car or a player car. We have a problem there though, and that's because in the player car, we're now overriding this function, which means it won't be called on the base class. So what we'll do is make sure we do call it by invoking super, open and close brackets, and we need to send in the delta there as well. You're still going to have loads of red. It will go away at the end. Okay, so then we have all of the applying throttle, get steer factor, and apply rotation, all this kind of stuff. And this is purely specific for the player car. And in fact, the physics process is specific as well. So I'm going to go from physics process, apply throttle, get steer factor, and apply rotation. I'm going to cut all of those brutally out of there, go to player car, and then paste those down here in the bottom. So now we've got all of the updates being done specifically inside the player car for the player car. Let's go back to car and have a look. So the region state here, we're okay. The region bounce, we're definitely okay. The region slipping, we should be okay. Now we have the lap completed and the hit verification. So lap completed is actually going to be needed on the computer car as well. So we will leave this here, but obviously the lap completed for the player car doesn't involve, involves verifications, and the AI doesn't. So what I'm going to do is I'm going to copy these and then come back and delete them from here in a moment or make them smaller. So I'll go into player car and all the way down here, drop in the lap completed, and then remove the lap time equals 00 here. And then at the bottom, I'm actually going to type super like this. So we invoke the super, then go back to car.gd. And then in car.gd, the lap completed, all that can do simply on the base class is reset the lap time, and anything that's in common with both of them we can add in here later on. And finally, hit verification we don't need. So I'll do Ctrl+S to save, and the red has all disappeared, which is a good sign. I'm wondering how this is all going to work. We're soon going to find out. So now we've got in the base car class only the code that's going to be used by both the player car and the AI car, and the player car should have everything inside it now that's related purely to the player car. So let's go back to the track then. And in the cars holder at the moment, I'll go to 2D view actually. At the moment we have a car here. It's no longer a player car. So I'm going to actually delete this out of here and then select the car holder, instantiate and instantiate a player car there. That's all the way at the top. So grab hold of this and drag it down and drop it inside here. So I'm quickly going to go away now and make sure this is working, and I'll be right back. And it is indeed working, which is good. So I'll close that down, close down the output. I'll go to the track.gd. So inside our setup here, we've got if car is car, which works fine here because the player car is a car, but the setup with the verifications is not something we'll need on the AI. So let's change the type here to player car. Okay, so now we can work on the AI car. And we'll do the same process as what we did with the player car. So we're going to subclass or inherit from the car. So I'm going to go scene, new inherited scene, and we want to go to car and select the car scene here, click open. We get the yellow nodes. I'm going to call this, I think, CpuCar, and then Ctrl+S to save, and save that in our scenes as well. Then with the root node selected, make sure you've got the CpuCar scene, not the car here. I'm going to detach that script, reattach, look for our car type, and we'll keep the empty template, and all looks good to me. So I'll hit create. So with that CpuCar, let's go to 2D view. What we're going to do for a bit of debugging is we're going to add a sprite to this actually. So I'm going to add a sprite 2D, and the texture can be the famous dot here. Where are you? Dot. A little bit big. So go to transform and change the scale here to 0.15, something like that. That's better. Then go down to visibility, modulate, and drag the sliders down, leaving the red one higher. I just want some red, something like that. So what we're going to do is going to basically put this at the next target of this particular car so we can see what it's actually navigating to with the waypoints. So do Control S to save, then drop back into the script for the CPU car. Let's give ourselves a class name for this one so we can type this properly. CPU car looks good. And we're going to set up now a very minimal version of this for this particular video, and we'll build on it over the next videos. So minimal means literally we're just going to have some fixed speed, fixed steering ability, and it's just going to go from waypoint to waypoint. So I'm going to make a constant, and that constant is going to be called steer reaction max. Later on we'll have a min, and depending on the skill and things like that, they'll have different values between the min and the max being the most sensitive steering and best cornering ability, let's say. Then we're going to export a property, which is going to be the waypoint distance. This is the distance it has to be from its target to have reached that target and be assigned then the next waypoint. And we're going to set that, or I'm going to set it to, by default, 20 pixels, but importantly configurable in the inspector here such that we can tune this either car by car or level by level if we need to. And then another export that I'd like here actually is also a debug. So we'll export a var, that's going to be debug, and that's going to be a Boolean, and we'll set that equal to true to start with. And what we're going to do with this one is simply set the sprite here, which is not a good name actually. I'll put that target sprite. Let's drag in a reference to that. We're going to set that visibility to the same as debug, basically. So we can do that already actually in the ready. So we'll do func ready, and then we'll set the target sprite visibility equal to debug. Now I'm going to check the car.gd. Do we have something going on in the ready? Not at the moment anyway. So go back to CPU car. We don't need to invoke super or anything like that because the ready is not being used inside the base class here. Okay, so back to the CPU car then. So next up then, we'll add in some variables which are going to change throughout the life of the car. For now, everything will be hard-coded and static. Later on, as we do the skill and things like that, we'll make them variable. So the first one is going to be something called an adjusted waypoint target. And the reason it's called adjusted is because, as I explained in the AI video, we're going to not go always specifically to the waypoint. We'll be adjusted to the left or the right of it. For now, we'll always be at the waypoint, but later on, we'll be using an adjusted value, hence the adjusted waypoint target. Then we're going to have another one for the steering. Again, something that will be adjusted later on, but will stay static for now. That's going to be the steer reaction. That's going to be a float, and that will be equal to our steer reaction max. Then we'll have a target speed. So this is going to be, well, our target speed, what it says on the tin. Again, fixed for now. And what should we fix this at? We'll fix it at, say, 250.0. This is going to be the speed that we aim to go at each frame, and it'll be adjusted according to the radius of the corner that we've got coming up. I think I talked about that in one of the earlier videos anyway, for sure. And then finally, we want to keep track of the next waypoint that we're aiming for. So we'll make a next waypoint, and that can be set up in later code. So at the moment, that is null, effectively. Okay, so with that setup done, what we can do is start building the physics process, and then lastly, the getting of the waypoints. So I can type, and then we want the physics process. And first of all, what we're going to check is we're going to check that if our state is equal to driving, because if it's not, so if it's not equal to car state driving, we need to return. Equally, if we don't have a next waypoint, we should always have one, but if we don't, then we'll also return as well. And we need a not, Richard, in front of there, otherwise big problems. Otherwise, we're in driving state and we have a waypoint. So what we want to do is two things. We want to move towards it, and we also want to rotate towards it, but we don't want to rotate instantly. Otherwise, it looks really jagged and jerky. We want sort of a smooth rotation towards it. So I'm going to make a var TA for target angle here, and that's going to be the angle that we want to actually get to, but we're going to go there using linear interpolation. So we're going to get then the angle between our adjusted waypoint targets minus our current global position, and then we can do dot and angle there. I'll go into distraction-free mode. It's a bit easier, hopefully, for you to see. So we've got our target angle, and what we can do then is rotate towards that. We can do that using lerp angle. So we can do rotation is equal to, and then lerp angle. We want to go from our current rotation. We want to go to our target angle, and we want to do this relatively slowly using our steer reaction multiplied by delta. As I've explained, later on, there'll be different skills which will have different levels of steer reaction. Now we want to deal with the velocity, and that's going to be a similar thing. So we're going to get our velocity, and we're going to linear interpolate with that. So we're going to lerp from our current velocity to our target speed. And we'll simply use delta in here. We can add a multiplier later on in there, but I think in my testing I actually found it was okay just to use delta. Now that we've done that, we can update the position. So we can get hold of our position, we can do plus equals, and then the transform.x multiplied by our velocity multiplied by delta. Now we do have this line already in the PlayerCar code. There is an argument for making a one-line function that simply does this and invoking it then in the base class, but I'm not going to do that. If that's okay with you, we'll leave that here for now. What we do need to do though, lastly, to get this actually up and working is we need it to know where it's going. At the moment, this adjusted waypoint target is simply 0, 0. So it does need to know where it's heading next. So to do that, we're going to write a couple of functions. One of those is to set its next target, so set its next waypoint effectively. So I'll write a new function called setNextWaypoint. And we'll take in a waypoint there as a parameter. Then we'll set our next waypoint equal to the waypoint. And now we want to set our adjusted waypoint target. Now for now, that is simply going to be the global position of the waypoints. We'll get the waypoint dot and then a global position. Later on, that will be adjusted side to side based on the raycast collisions and things like that. What we can also do is get hold of our target sprite here, and we can set the global position of our target sprite also to be equal to our adjusted waypoint target. And now we can invoke this function from inside this code here each time we reach a new waypoint, but crucially from outside this as well, which we'll be doing in track when we come to set up the car. Before we do that though, let's do the final function for now that we need in here. And that's simply to understand whether we've reached a waypoint or not. So I'm going to call this one func, and let's call it update waypoint. And here we need to understand if the distance between ourselves and our target is less than our, waypoint distance all the way up here. So we can say if our global position dot the distance to our adjusted waypoint target is less than the waypoint distance, then we can set our next waypoint, and that will be then our current next waypoint dot and next waypoint. So it's the next waypoint of that waypoint that we're looking to set. And I think that's pretty much all that we'll need. There is one issue. The target sprite here, we're setting the global position on that, but as the car drives around the track, if I can find the track, it's going to rotate with the track, and that will cause this target sprite to rotate with it because it's a child of that. But what we can do if we come out of distraction-free mode is go to the CPU car, select the target sprite, and then on the right-hand side, we can make it top level, and then it will ignore its parent's rotation and everything, and you'll see it'll jump from waypoint to waypoint and won't be affected by the car at all. So we have one last thing to do. If we go to track and open up the script, what we want to do inside here is when we have a CPU car, what we want to do is assign it the first waypoint on track processor. If we go to track processor though, I think our waypoints list looks like this. So what we could do is write ourselves here a little property just to get the first waypoint. So we'll call this first waypoint. It's going to be of type waypoint. And then we can put a getter on there. And we'll put a bit of a debug check here, actually. We'll say that if waypoints.size is equal to 0, we have obviously some big problems. So we'll print here an error. Where are we? Print error. And we'll print something like first waypoint, not there. Let's say, I can't think of anything better that'll do. And also put the track processor in here as well. And then we can return null. Now this will crash the program, but that's not a problem because we'll have something in the error anyway to tell us what's gone wrong. This should never happen. Otherwise, we're okay. So we're going to return then our waypoints at index 0. So that's the first waypoint. And this is what I was talking about when I said that if I go to our track, we have to be a little bit careful with where the cars start and the start line because we are assigning hard coding or going to assign the first waypoint. So with this property or this getter written here, we can go into the track.gd. And then finally, what we can do here is we can say that if our car is a CPU car, then we can take our car dot and we want to set the next waypoint. And that needs to be our track processor dot first waypoint. And breathe. So all being well now, what should happen is we should be able to add a CPU car into here. I've got the feeling I've forgotten something. We're about to find out. We should be able to, a CPU per car and position this CPU car as well. Where are you? Somewhere around here. And then if we run the application, we should see it. Yay, drive. Oh, okay, we see it spin in a circle. That's good, isn't it? It did go to the first waypoint. What? Script, CPU car. Okay, I've forgotten to invoke the update waypoint at the end of this process. Sorry about that one. We're nearly there with this. So Control S to save there. Please work this time. Let's see. There we go. Cool. Okay, it's definitely driving now, waypoint to waypoint, and we can also use that little debug sprite there, the famous dot as well, to actually see where it's intending to go. And that looks all right to me, actually. In fact, I'm going to close that down, close down the output, go back to 2D view and take off the paths and collision shapes just so we can see it as nature intended, so to speak. Oh, we've still got the debug on the waypoints, never mind. But yeah, that's not looking too bad now at all, I think. The car looks like it's now driving around the track reasonably well. We could clean this up even more if we wanted. I'll select the car and check the debug. And we want to go to our waypoint scene and hide the label there because they seem to be working well. There we go. That's a much better view of what the car looks like. And even though it's following the path, it actually looks not bad just with the fixed waypoints there. If we varied the speed a little bit, it would already make for quite a good game. But as I've already described, we're actually going to slow it down into tighter corners, speed it up along straights, and give it some variation along the path as well. But that is already not looking too bad. To finish this video, there's one tiny thing. I think we should make it so that we can change the sprite, actually, because there are a few different cars available. So let's do that to finish off, shall we? So let's open up the car, and we can open up the script of car.gd. I thought we already had an export up here for this, but we don't, which is unfortunate. So let's make another export, and I'll call this car texture. And that's going to be of type texture 2D. And we can set here a default value. That's not a valid default value in here. We can either set nothing or a default value, actually. Let's set a default value. So I'm going to clear that filter there. Let's go to Assets and Images. And then I'll control drag the car red here, and that appears there. And we can then change that. So we can set this up actually inside the ready. So the ready at the moment has pass. Do we actually have access to the sprite? So we've got the sprite 2D here. Okay, so I'll change the name of this to car sprite. Let's drag ourselves a reference to that. And then inside the ready, we can set up the car sprite. So the car sprite.texture, that's going to be equal to then the car texture. Now we are invoking ready in at least one of the children. In the player car, are we invoking ready? No, but we are in the CPU car, aren't we? I think yes. So what we'll do here then is we'll also do super here. So that is applied. All right then, so 2D view, back to the track. And we should be able to select, say, the CPU car here, go to quick load, and let's say change it to the pink one here, and then run this. And we should now see, yeah, it's got a different texture on it. Cool. Excellent. So I'll press F8 to close that down, close down the output. That was a tough one, that video, I imagine, for you. There was a lot to do there, especially before we could actually run something and see what we'd actually implemented. In the description to this video, you'll find a link actually to the current state, as you see on the screen, of this project from me. I'm literally going to save it now and zip it up and make it available for you. So if you had some problems with the code and things during this particular video, you can always restore yourself to the same state I'm in. And more than likely, there are hidden bugs in here from me anyway. We will find out probably later on. But we've hit a really good place now with the application because we've got the player car and the CPU car separated. We've got the CPU car able to follow its way around the waypoints and also the racing line. And what we can do in the next few videos is start building out this AI behavior to give it some variability. So thanks again for sticking with me through this one, and I'll see you for AI behaviors in the next one.